This is the activity on Anova, analysis of variance. We're going to guide you through how to do this type of analysis. It's actually a hypothesis test and similar to what we've been doing, but a few little extra steps along the way. So when do we use Anova? As we get started into this, I encourage you to go ahead, if you don't have this already, download the Anova overview and worksheet. I have it ready to take a look at. It looks something like this. There's a front page with the data and the calculations we're going to be using, what they look like. Then there is a page here where you can actually fill in the calculations we're going to be doing. And there are the formulas here. Now, if you don't have a printer or something, you could just create a table like this on a piece of paper. That would be fine. So this is what we're going to fill in, though, each of these squares. The total is not so important. We could do that, but we don't really need those. And yeah, these totals are not going to be needed. And you'll see that by time we get to the F value, there'll just be one here. But these top ones, the top three, the middle three, and the F value is the ones we will be completing. Okay, that out of the way. So analysis of variance. Let's take a little look at why we do this. So when do we use it? So far, we do not use it when we only have two groups. Our calculator and many other, there's the t-test, the regular t-test, the pool t-test. There's z-tests if we know the standard deviation of the population. So we've been doing those type of things with comparing two groups. And that type of testing is built into the NumWorks calculator. And we've got either the student's t or we're using the normal, right? Those are very similar, but we would use one of those two distributions and we'd go there. What we're going to see with the Anova, what we're going to end up using is called Fisher's F. This is a different distribution. You can kind of see it's got a different shape. We'll talk about that a little bit more later on. And where this comes into play is whenever we have three or more samples. So we would want to compare three groups or more. The example we'll do is with four groups. And we want to see, is there a difference between the means? That's, again, very similar to what we did with hypothesis testing with either the T or the pool T or the Z. But now we use Anova for this situation when we have more than three or more. So the example we're going to look at is we'll look at the factors. And again, this is a designed experiment where we're taking different octane gas. And if you've ever filled up a car tank, you will know that generally in the US you have the choice between 87 octane, 89 octane, or 91 octane, which is premium. In Thailand, in other countries, actually they have a 95 octane, and they do have this 93 as well, so they have higher octane. The idea is that the higher the octane may be, what we're going to test, does that mean that the vehicle will have higher horsepower? So we're going to do a designed experiment with each of these octanes. We'll take a sample of measurements of horsepower after using each of these, and we're going to do an Anova test on this. So the first thing you need, since the Anova is a hypothesis test, is we need the two hypotheses, the null hypothesis and the alternative. What we'll use for the null hypothesis is the concept that they're all equal, right? Null is always has the equal part. And what we're going to use for this one is that octane really does not make a difference in horsepower. So that would mean that all four averages of horsepower would be equal to each other. At least there's no significant difference between it. That's our null hypothesis. If we reject the fact that they're all equal, what would be the alternative? The alternative is that they are not all equal. So at least one is different. That's all the Anova gives us. It doesn't tell us which one is different. It would just tell us, hey, if you reject the null, that's telling you that one of the means is not equal, and so you could accept the alternative that in some way Octane does make a difference, but then you would have to do more testing to figure out what kind of a difference, whether it's whether you get greater horsepower or less horsepower, and if it's across the board or not. Okay, but it will tell us that there's evidence that Octane does make a difference. The null says Octane does not make a difference. So that's our hypothesis test. This is the data we're going to use, and the way the analysis of variance works is while we're looking at the mean, um, we are going to measure the variation within each set of data. So in this case, you can see that there is variation within each sample. So these numbers are not all the same. They vary over. They're close, but they're different. There's 91 is sort of a high, and 85 point something is going to be a low. I think 85.3 looks like the low, but there's variation within here. So that's one calculation we're going to do. That's called the mean sum of the errors. And then there's also variation between the groups themselves if we look at the means. So this down here, we're going to have to calculate that anyway, is the mean of each of the samples. See how we calculate that. Come back to this if you want to kind of verify that your calculations are correct. And that's called the mean sum of the treatment. So there's these variations. And what the Anova does is it takes the ratio of these two numbers and then comes up with an F statistic, and that will tell us whether we reject or fail to reject. Let's take a look at what's going to happen. So these are the calculations we're going to do, and we'll get on that with a sheet. Again, I've got the data already entered in for us, so that's going to be helpful. And we'll do that with Google Sheets. So what we're looking at, the results. If we fail to reject the null, that's basically saying, well, the null must be true, or at least we don't have evidence that it's false, right? It would mean that what's happening in the test is that the variation between each of the factors is about the same as the variation within the factors. So any differences are just due to randomness, to sampling. There's not due to anything else. And what will happen is when we take the ratio of these two values, the ratio of the treatment mean squares of the treatment and the mean squares of the error, the variation with the variation between divided by the variation within, that we'll get about 1 because they're going to be about the same. Okay? What's going to happen if we are able to reject the null is the opposite, that there is actually greater variation between the means than within the means, which means it's not just randomly something that's happening, but there's a physical reason why there's a difference, a greater difference, greater variation in the means of the treatments rather than the means within each group. And what's going to happen when we take that ratio, that same ratio, we don't get 1, we get a large number because the variation between the treatments is larger than the variation within the treatments. So it's not randomness that's causing this. We'll get a large number. We reject the null and say, hey, Octane does make a difference. It gives us greater horsepower or maybe less horsepower. We don't know that. We'll do some more testing, statistical testing with our samples to see which direction it is. Okay. So now we're ready to go ahead and do these calculations and see whether we reject or fail to reject. There's a link here to the Google Sheets. So we're going to ask you to go ahead and click on that. There is below that a video that will explain how to use the worksheet. I'm going to walk you through right now, but in the future, if you were to come back and later want to do this on your own and just didn't want to see the introductory part, you could see this part, and that's a separate video just with the worksheets. Okay. I'm going to click on this. One of the things I forgot to do in that special worksheet, though, was to tell you, I think, that you can't edit it as it is. You don't have editing value um, authorization. So what you need to do is go to File, and you need to make a copy. You can edit a copy. So you're going to make a copy, and you're also going to share it with the same people, which means anyone with the link can see this, so that if you upload that link to the gradebook, I'll be able to take a look and give you credit for this activity. So that's kind of one of the easy ways to do it. So we're going to make a copy, and notice it's going to give me a copy. I'm going to click on the tab and close out the original just so I don't get confused. And this is the worksheet we're going to work with. So part of it is learning how to use Google Sheets. This is very similar, works very similarly to Microsoft Excel. So if you've got if you import this into an Excel, the steps will be very similar. What we are going to be working from is that worksheet, the second page. We're going to be using these formulas to find the variance. And what we're going to start with is the sum of the squared errors, or the within variation. So what we're doing is we're going to take each data value, and we're going to subtract the mean of that data, of that group, square it, and then add them all together. Okay, so that's the calculation we're going to be making. And the way we do that is we come over here. What we need first is we need the means. Now, it was on the table. We could have entered it, but I want to show you how easy it is to find an average. We could add these together, divide by 10, or we could use the feature here. If you click on these three dots, that gives you more. And this little sigma is the list for inserting functions. There are all types of functions you can use, and this is got a few here that get used a lot. Also, if you come down here, there is a separate grouping of all the statistical um, calculations that can be done. Okay, but we're going to use just really the simple ones. We're going to get the mean, which is the same thing as the average. So we'll do the average, and what we need to do is put what values we want. We reference each cell by its number, B. In this case, this one is B3. However, there's a nice feature. I'm going to click with my mouse, and that's going to be a left click, and I'm going to hold. So left click and hold. Notice it changes colors, got the little dotted lines around it, and I'm dragging my mouse down to include all of the numbers, all 10 numbers in the calculation. And then since it's going to take the average of those 10 numbers, that's what I want, I just hit enter, and it's done that. But notice this number 169.7 is actually not stored in the cell. What's stored in the cell is the formula to calculate it. So now what I'm going to do is, once I've clicked on this cell, I'm going to do a Control C, or Command C. I think it is on a Mac. It depends on whether you have a Mac or a PC, but do your copy, Control C. The other way you could do it is you could right click and do a copy this way. And notice it gives you the little um, Control C or Command C, um, one way or the other. So Control C, it's highlighted, so that's what's going to be, that's what has been copied. I come to the next one, and I'm going to paste it. I can do that with the Control V. Notice it has pasted, but it did not paste the number, it pasted the formula, but it now knows it's in column D, so it's referencing D3 through D12. Okay, so notice how as you paste it in a different place, the reference to the cells themselves will change. And we can do that here. I could do a paste. Well, actually, my computer won't let me. It says you got to use a Control C or Control P for paste. Okay, so I'll do that unless I install something else, which I've never taken the time to do that. I'll just do Control V. And just make sure you're in these blue boxes, and that is going to put the means in there. And then again, you could come back here and check that up here, they should be the same numbers as these. If you have different numbers, what has probably happened is that you only came down and maybe got 9 of the cells somehow, or maybe you didn't start with the first one. So if these numbers are different, you probably didn't get all 10. Or something has happened and one of these numbers got changed. But if you have the same numbers here, you will have the same number here. That's the idea. And the formula is, again, going from 3 to 12. So now that we've got the means, we can calculate the deviations from the mean. And so we will do that right here. That's the way I've set it up. Since we're doing sort of a custom calculation, and again, the calculation we're going to do down here, we're going to take the data value minus the mean of its group, of its factor, and then we're going to square it. So I'm going to put an equal sign. That tells Google Sheets that you're going to put a formula in here. I want to take this number, B3. You could type it in as B3. And again, we want a parentheses first, so I'm going to put the parentheses. I could type in B3, or I could just click on B3, and it does it for me. I'm a little lazy, so I like to do it this way. But more importantly, it highlights and colors and lets me know what I'm doing, so I know I've got the right cell. Then I'm going to subtract the mean, which is down here, this 169.7. I'm going to click on it. It pulled it in. Now, one thing, remember when we copied and paste, which we're going to eventually do, it will change the reference. And since we're going to come down here, as we copy this down, it would change that reference from cell 14 to 15 to 16, and we don't want that to happen. So one of the things we're going to do, you'll see that this will work, is we're going to put a $sign right in front of the 14. So we're going to go B $14. And you'll see that what that's going to do is freeze cell 14. And we're not going to freeze the B because we're actually going to copy this over, and we want it to change columns as we copy over to the right. But we don't want that 14 to change. We want all of these are on row 14. Okay. Just follow along, and some of these things hopefully will make more sense as we do it. We put the last parentheses, and then we want to square this. We do a shifted 6 that gives us the chevron, which is the exponent key, and we put the number 2. So now we have our formula, and we get 0.8. It's going to give us a suggestion, and actually you could just accept these. These are correct. I'm not going to do that because just in case this didn't come up, I want to show you how we do this. We can copy this formula downwards. The way I like to do it is, notice how my cursor changes. It's going to grab and drag it there. If it's a plus sign here, and again, maybe you want to increase yours. PCs work a little different, but as long as I've got this corner, if I click, I'm left click and I'm holding it and I'm dragging it, see, I can drag this down. A little skill. What it's dragging down is going to copy that formula, but notice it changes it slightly. So now this is B4. It's referring to that cell, and it's doing it for each one, but notice it's keeping it as B $14. So it's always referring to the mean. So it's taking the data, subtracting the mean, and squaring it. I've got all of those, and I'm well on my way to calculating this. The last thing we need to do down here is we need to add all of these together. So we're going to put in this formula, equals, and it says, do you want the sum of, yeah, that's what we want. We want to take the sum, and again, again, if you want to change it, what you do is you highlight it here, because sometimes it says, is this what you want to do, and it's not what you want to do. So I just want you to see both ways. Now, definitely we don't want that cell there, so I don't take its auto suggestions. But this is what we want to do for each cell. Now we could go through and you could set it up the same way, entering each one, or you can click here in the middle. Don't drag, so don't do it on the corner. Do it in this middle section so it's still pointed. This is going to select all these cells all the way down to this one, the cell 13, row 13, and we're going to copy it. So we will do a Control C. Notice now that I've done a Control C, it's got dotted lines around, says that's what's been copied. I'm going to come to the next treatment, the 89 octane. I'm going to calculate its deviation squared by going Control V. And that pastes, again, not the numbers, but the formula. And I get this variation. and I can keep going even though it's not highlighted anymore. If I do a Control V here, it remembers the last paste and it's copying all that over. And notice this is taking still the 14, which is the mean, but it's F14. It's not taking B14. So again, it's very, you've got to get the coding correct. So this is more computer science type stuff than math, but we use it within math. Okay, so I have the deviation squared for each of the treatments. So this is the within variation. The thing I need to do now is get the total of all of this. And so I've color coded. I want the sum of squares of error. That is going to be adding each of these together. So I can go equals sum, and remember I can choose these values. Now, since I'm going to not just choose a whole column, a whole row or column, I'm going to choose individuals. I need to put a comma between these. So I'm going to take value 1, click there. That's the one I want, comma. I want the next one. Notice it changes the colors, but it's showing me what I'm selecting. I want that one, comma. And then this is the last one. Don't have to put a comma. I just put an equals or an enter, sorry. And it's calculated all of these 3 together. For some reason, that number doesn't look right. Oh, of course it's not right. I'm going on the wrong numbers. Glad I've done this before. So I didn't want the means. I wanted the sum of the squares. I wanted these, so partly I was doing the blue ones. That's not what I wanted to do. So I can come up to this formula bar and delete it. Let's try this again. We're going to go equal sum. What I want the sum of is this here, right? I want all of these sums I want to put together, comma, sum, comma, add that one, comma, add that one. Enter. That's the number I was looking for. Okay. So we'll see. And so that color coding, matching, hopefully you probably said, what is he doing? He's crazy. He's adding the means together. But we did want to do that. Okay. We'll come back to the degrees of freedom. We're going to calculate the sum of the squares of the treatment next. So the sum of the squares of the treatment is we're going to see what's the variation between these means that we've calculated. But remember, the calculation involves you've got to take the data value, which in this case is a mean itself. We're going to subtract what we call the grand mean. And the grand mean is the mean of the means. So we've got to calculate that. And then the formula is showing us we take the number in each sample, which is 10. Sample size is 10, treatment sample size, and then we square that. Okay, so it's going to be a similar calculation, but a little different. First thing we need is this grand mean. I've got that also color-coded in blue. So we want the average of the means, the mean of the means. So I go equal, actually I don't have to do that. I come over to the formulas and ask for the average. And again, I'm going to use commas between these because I want these individual cells. So this is where I want this one, comma, this one, comma, this one, comma, this one. Now it's not just adding them together, it's adding together and dividing by 4 to get the average. That's 178.7. Okay, and you should have that same value. Now what I can do here is to calculate the sum of the squares of the treatment, which is going to be the green. I'm going to do it here right in this table. So I'm going to take the mean of the, see if I bring this down, the mean of the 87 octane minus the grand mean. We're going to square that and multiply it by 10. Or let's do the multiply by 10 first. So I select the cell, hit equal. I'm going to then take 10, and to multiply you can do a shifted 8. That gives you the little asterisk. And then we're going to put a parentheses. I'm going to take the mean of the 87 octane. I'm going to subtract the grand mean. And since I want this grand mean to stay the same, because I'm going to copy the cell over, you could just redo it, but I'm going to put a $sign in front of the B and a $sign in front of the 16. So it's freezing the reference to just this cell B16 by doing that. Okay, and you'll see that that will work when we copy it. If you didn't do that when you copy it, you're not going to get the same values. You're going to get something different. We want to square this, so I do a shifted 6, gives me the caret, and I put a 2 to square, and then enter. And notice if you want to check that formula, there's a formula bar up here. This is what I've gotten entered. Equals 10 times the mean of 87, octane minus the grand mean, all squared, and then we're going to do that. So I can actually copy this with a Control C, and notice it shows that it's copied now. I do a Control V, click here, Control V, click here, Control V. And notice that what's getting copied over is a reference to the cells. Wait a minute, what's going on here? Okay, yeah. B14 minus that. So this one should be H14 minus B16 squared. Okay, so that's it. Then what I need to do, again, color coding, I need the sum of these differences of the means. So I'm going to put in equals the sum. And again, I'm going to click on the values, remembering I'm in green, so that should hopefully get me to the right place. I'm not going to go to the wrong place this time. Comma, this one, comma, this one, comma, and this one. I've got those 4 are now added together. And I should get this number, about 1,829.6. And we're almost there. What we need to know now to do our division is we need to talk about degrees of freedom. So the degrees of freedom of the treatment, its formula is A minus 1. A is the number of treatments. We have 4 treatments. So 4 minus 1 is 3. Didn't need any special calculation for that. Degrees of freedom for the error is this formula. It's the number of treatments, 4, times, parentheses, the quantity, n minus 1. N is the sample size, which is 10. So we get, this one I might write down, we get 10 minus 1 times 4. So that's 4 times 9. That's going to give us 36. Okay. Degrees of freedom. And we'll see, we'll use these in a couple ways. Now the last part of these calculations, this mean, what do they call this? The mean squares. So the average of the squares is the sum of the squares divided by the degrees of freedom. Okay, so that's going to give us our average. So I can just do an equals, click on the numerator, and I do the division, the backspace, or the, not backspace, the backslash key, divided by 3. And I'll do that calculation. For the mean of the mean squares of the error, we're going to divide these two, the SSE divided by the degrees of freedom. Again, getting that average. So I'm going to again go equals this number divided by this number. And that gives us about 4, a little bit bigger than 4. The F statistic, as we can see over here in this formula, is just the mean squares of the treatment divided by the mean squares of the error. So these two numbers being divided. The other one's there. So I just put in equals. I click on this one, is in the numerator, divided by this one. And we get our F statistic. Now, you could fill them in the table. What we have here, for to do this, the sum of the squares was, I'm just going to round these because, again, whatever, we'll round it to that. Error within is 147.9. Degrees of freedom, we calculate that's 3, and that's 36. We did the division here. This one is 609.9. Down here is 4.1. And then when we divided it, we get the F statistic, which is 148.4. So this is the F value, the test value. And again, in the past, our calculator would give us that for the t-test and the z-test, gives us that test value. We need to compare it to the distribution, to the critical value. So how do we get the F critical value? Well, that's where we can use our NumWorks calculator. We come, again, remember, to show you, you might start up here, we come down to distributions, say OK. At the very bottom is this Fisher's F, you say OK. It asks us for the degrees of freedom of the numerator. That is the one in the top, so that's 3. The degrees of freedom of the denominator, which is 36. And then we get our F distribution for that. What we want to do is, where is the rejection region? Well, notice the way this is set up. Remember, if it was equal to 1, we wouldn't reject it. And notice the way this distribution is most of it is in the left part of the tail. It's got a skew to it. Rejection region for an F distribution is always going to be to the right. So what we have to do is come here and change this to be the greater than or to the right. Okay? And what we want is, what is our alpha level? Where is our rejection level? Now, we didn't say what it was. Maybe we should have, but let's go with a 5%, 0.05. You could go with a 1%. What you see is we could do a 10%. We'd reject them at all of them. But this is at a 5% level. Our critical value, our rejection, is 2.866. Notice, if we're bigger than 2.866, we're going to reject. And our F value is actually 148. So here's 5. It's like we're way out of here. Got to go to the next classroom probably to graph that one out. We are definitely in the rejection region. So to finish this off, what would we do? We will say F critical was 2.866 or 7. We compare with this test value. 148.4 is much larger than 2.87. This is the test, this is the critical. And this is where we would decide to reject the null. Notice we didn't get the alpha level because this would be very hard to calculate. It's a very, very small. This is going to give us a p-value. We didn't calculate the p-value because it would be a very, very small probability, probably close to 0. It would be so small, we would call it 0. So in this test, we just compare the F statistics for each of them. So that's how you can complete it. What you can do now is you could copy this link, and then in the assignment, back here, what we've been working in is actually an assignment. I'll see if this works. I may have to update it. But when you click on Start the Assignment, you'll be able to either drop a file in here if you wanted to sort of take a picture of this. That's evidence that you've gone through it. Or you could actually click on Google Drive. I will activate this. I don't think it's currently activated, but I will allow this, and then you could put that link in there. So yeah, okay, it doesn't let me do it because I'm in a sort of a fake student mode. But in student mode, you'll be able to go to Google Drive and put that link. And then your file will be there, and I'll be able to see it too in the gradebook and be able to give you the points. All right. Or the other option is this one allows it. You could use your webcam and you take a picture, upload it. Take a picture of what? Take a picture of this. Okay. All right. So that is our Anova.